This is ECC. It's an agent harness framework, about 3,500 files, so a fairly typical repository. It's open source, and I'm considering using it. Which means the question I actually care about is whether I'd let it run autonomous agents against my own code. So I'm going to point Claude Code at the source and investigate. 4 questions, in the order I'd really ask them. Top terminal gets grep, bash, and read. Bottom terminal gets read and miru. Same model in both, same commit, same prompt typed into both. One thing before we start. This is a real run, not a mock-up, but I've sped up parts of the playback so we're not all watching the agent think. The timings and the numbers you see are the real ones. Where are agent hook definitions validated for correctness? Everything in ECC hangs off hooks, so that's where I start. Both of these will get this right. It isn't a hard question. Watch the cost. Same answer, both of them. 74 cents against 33. Miru is a shade over twice as cheap. And it isn't trading time to get there. 105 seconds, down to 56, roughly half the clock as well. Where is model spend tracked or capped during a run? Here's the thing that makes this one investigation rather than a list of questions. The cost tracker in ECC is itself a hook, so this follows straight on from what we just found. 57 cents against 16, 3.5 times cheaper, and the gap is widening. The clock isn't close either. 2 minutes 9, down to 42 seconds. And there's something quite pleasing about asking a tool how this framework controls spend, while it demonstrates controlling spend. How does ECC keep multiple agents working in parallel from clobbering each other's files? If I'm running 4 of these at once against one repo, what stops them overwriting each other? This is the question I actually cared about going in. $0.88 against 21. That's the widest gap in the whole run, 4 times cheaper. 2 minutes 28, down to 52 seconds. Where is the logic that installs ECC into different target editors and tools? My team is split across Cursor and Claude Code, so the practical question is whether this installs into both. Watch the shape of the top terminal. Grep, read, grep again, read again. 99 cents against 30. 2 minutes 35, down to just over a minute. But the cost isn't really the point on this one, it's how it got there. Semantic search found the answer in a different language from the one the question implied. And that's the case keyword search structurally cannot cover. You can't grep for a concept when you don't know what language it's written in. Where is the Prometheus metrics exporter and Grafana dashboard? Last one, and it's the one I care about most. Not because I need Prometheus, because I want to see what happens when the answer is no. There isn't one. ECC has no Prometheus exporter. Both of them said so, neither of them invented one. 53 cents against 25. That's the failure I actually worry about. A search tool that guesses a file name when it can't find one is worse than no search tool, because you don't find out until 3 commits later. So this one's a draw. Both of these did the right thing. Across these 5 queries, $3.71 down to $1.25. 66% cheaper. 11 minutes 9, down to 4 minutes 19. And I never had to go back to the top terminal for something the bottom one had missed. Now, I picked these 5. They're the questions I'd actually ask about a repo I'm sizing up. But they're also the shape of question miru is built for. Where is X, and how does X work? Miru gets me what I need for about a third of the cost. Which changes something small and real. When the 5th question costs what the second one used to, you stop rationing them. You ask the one you'd otherwise have guessed at. $1.25 to work out whether I'd trust someone else's framework with my own code. Try it now. What will you build?